Alright. Hi everyone. I think we can start now. Thank you all for coming. I hope you guys are all having a great day today and you're all staying safe. Welcome to learn.py. My name is Sneha and this is my co-director Hannah, and we're super excited you guys could join us today, and we'll get started so that we can start on the workshops as soon as possible. Okay. So here's the link to the slides in case you want to follow along. And I think someone, if it has not already been dropped in the chat, will drop it in the chat right now so that you guys can click on the link if you would like to see them. Okay, so for our quick intro today, we're just going to go over what is learn.py, some installations you need to do on your laptop, what are virtual environments, and Python libraries, and some more resources for you guys to follow along before we begin. Okay. But first, what is Python? In case you guys aren't familiar, Python is a programming language, and in fact, it's one of the world's fastest growing languages among a lot of different people, not just coders. And this is because it just generally has very beginner-friendly syntax and languages, and it's great for a lot of different tasks like data analysis, machine learning, object detection, scripting, and automation, because of all of the different libraries we have. And some of them we'll be learning about today as well. And today we're going to be covering kind of about object detection and also scraping and like automation. Okay. So specifically, what is learn.py? Learn.py is fun Python. So basically, our goal for today is to make it as project-oriented and hands-on as possible. So we want you guys to be able to actually like work with some different Python libraries and leave with a really cool project that you guys can complete. And we're also hoping today will be kind of beginner friendly. So even if you aren't super experienced with Python, we hope that kind of our workshops will be able to guide you through it. But for some of the things, just the mostly is we're going to be going over a few complex libraries. So we might kind of brush over some of the syntax things, but we have resources linked about general like Python basics and syntax as well if you guys would like to follow along. And we have a lot of really talented and knowledgeable hack officers here with us today. So if any of you guys have questions at any point today, feel free to like drop a message in the chat or raise your hand or anything, and someone will be able to help you out. Okay. Okay, so our schedule for today is right now we're doing a quick introduction, then we're going to jump into our first workshop, web scraping. Then we're going to take a quick break. And if you guys have any questions, you're feel free to ask them during this time or throughout as well. And then we're going to go to our second workshop, OpenCV, and then we're going to close out. Okay. And now we can start off with some installations.
So, as you probably know, we're going to need someplace to write our code today. So you're going to need a text editor. Visual Studio is a really good one. You can just follow this link if you don't already have it installed. It's what all of our officers are going to be using in their workshops. But also whatever you're comfortable with is also great. Also, it's going to be important that you install Python, which you can just do with this link. There's some more resources that we have later on about how to do this. And if you run into problems, just feel free to shoot us a chat or raise your hand and we'd be happy to help. All right, so another topic that we just want to kind of brush over before we get started is something called virtual environments. So when you're first starting with Python, it is kind of common to just install all of your packages in the terminal. However, as you start to get more complex and involved projects, you can have these things called dependency issues. So if you have like a project that requires version 2 of one package and another project that requires version 3, it can cause a lot of a lot of your code to break. So that's where virtual environments come in. Virtual environments are isolated spaces where you can work on your Python projects separately from your system installed Python and separately from other projects to make sure you have the correct packages you need for each of your separate projects. So in order to create a virtual environment, you're first going to need to install this package called virtual env. You can just do this right in your terminal. I have a Windows. I know a lot of you guys have Mac. I don't know how to access the terminal on Mac, but if you don't know how to access terminal on Windows, you can just hit the start menu and type in terminal or command line or whatever, and it'll pop up. And you can just install it right in there. Next, the command you're going to want to need or going to need to use is just this Python -m v and then whatever you want to name your virtual environment. In order to install, like actually create a virtual environment, you're going to need to have a directory for your project. So the example at the bottom just is exactly that. So these commands you can just type into your terminal, like I mentioned before. To make a new project directory, just make directory project A, get into that project, that directory by changing the directory to that project, and then making your virtual environment. And then in order to actually install the packages you want into these virtual environments, you're going to need to activate your virtual environment. So once you're in your new project directory that you just made, you can go into the terminal and type either one of these commands, depending on which computer you have. And that'll allow you to activate your virtual environment. And then from there, you can just PIP install whatever packages you might need directly. And then once you're done doing that, you can just deactivate it using the deactivate command shown at the bottom. One final note about virtual environments. I'm not going to do a demo because I have resources linked later on that do a much better job explaining it than I can. And we do want to jump into our workshops as quickly as possible. So the final note that I want to give, though, is there's something called a requirements.txt file that you can make involving your virtual environments. Virtual environments are not supposed to be portable, but they're supposed to be easy to recreate so that you can make your projects be able to run on different computers or in different ways. And in order to do this, you can just run this pip freeze command and then put all of your, it'll track all of your dependencies and put them in a requirements.txt file or whatever you name this text file, so that you can just share that with people or install them directly from there. And yeah, so I know I rambled a lot. I apologize, but there's some great documentation on how to use virtual environments. These are linked in the slides, and our officers are also here to help if you have any questions related to that later on.
Okay, thank you, Hannah. Let's just continue on and go over what are some different Python libraries. So Python libraries, as we mentioned before, Python is a super cool language because it has a lot of pre-written code and functions that extend the language and can be used for specific tasks. And it basically just makes it easier for developers to work without having to rewrite a bunch of code. And they can just like import the library at the top of whatever project they're working on and use all the specified functions um, that are already written within that library. So these are a few different Python libraries. You may have heard of some of them before. Today we're going to be working with Beautiful Soup, Selenium, and OpenCV. Okay, and here are some, oh, okay, yeah, oh, sorry. Before we move on also, if you guys are here, I would love if you could fill out this check-in form. We have a secret, not so secret prize raffle going on. So if you fill it out, you'll be entered within our pool of participants to win one of 5 plushies, and they're all really cute. These are some example pictures, so you guys should fill out this form. And I'm not sure if this has been dropped in the chat, but this will also be in the chat. Okay. And here are some extra resources if you guys are new or unfamiliar to some Python syntax or want to learn more about it. You can click on any of these links. These are also some slides from Hack from previous workshop iterations, which I think do a really great job of introing Python, like variables, classes, and like data structures if you guys want to learn more about that too. Okay. So thank you for listening to us. I know our intro was a little long, but let's get to coding, and I hope you guys are excited. We're gonna start with our first workshop, web scraping, right now.
Okay, cool. Give me just a second to share my screen. 1 second, 1 second. Okay. Hello, everyone. Um, my name is Anar. I'm going to be presenting today with Azel and Chiyu on a topic that is very near and dear to my heart. Well, at least one of them is very near and dear to my heart. Um, Fortunately, we are on Zoom today, but honestly, it's kind of a blessing in disguise because I would imagine a lot of you are back home right now, like for Mother's Day tomorrow. I want to encourage you to tell your mother that you love her because she's done a lot for you. So, yeah, make sure you do that tomorrow. Okay, here are the slides for this web scraping workshop. The link will also be in the bottom left this whole time. So you can just type this in. Maybe someone can drop it in the chat as well. But yeah, there you go. And this was just mentioned, but I highly, highly recommend that you fill in this form. You can get one of these very cool prizes. I love this seal. I think we've been trying to get a hold of it for like 2 years now, but we've never been able to get it. And I'm very excited that we're now that we have it now, which is great. I haven't actually seen it in person, but it is very chill and very cool. So yeah, fill it out. Okay. And before we get to like the actual meat, I did want to give some motivation for why you might want to web scrape in general. It might seem a bit tangential, but don't worry, I will get there. And I want to start by talking about the New York Times mini crossword, which some of you may have heard of before. Essentially, it's just a 5 by 5 crossword, right? That the New York Times produces every day. Uh, and they also have like a leaderboard too, where you can connect with friends and like basically compete to get the fastest times. I started doing it. I think my friend got me into it like a year ago, last April, and I don't know. I just like even though I was really bad at it at first. This is me. My name is Wiener. I'm seventh on the leaderboard. I think this is my first time doing it. I'm not 100% sure, but it was definitely early on in my in my crossword career. But yeah, so something about it, even though I wasn't great at it, uh, I just took a liking to it and I wanted to get good, right? So I set a goal, and that goal was to complete every New York Times mini ever made, right? So that seems like a lot. I think they first started making minis back in like 2014 or so. So 2014 to 2024, that's quite a few minis. And I did eventually actually complete that goal, but that's a whole nother thing. Um, I want to talk about so um, clearly I'm very obsessed with the New York Times Mini, and just to illustrate that even further, I was in the shower the other day. This is a real picture of me in the shower, um, and I was thinking to myself, man, I love doing crosswords. They are so fun. I just love them. And then I thought, well, what if I made an automatic crossword solver? That would be, whoa, that would be sick, right? Um, so, yeah. And then I thought about, okay, but how do I actually go about doing that? Like, is it even feasible to do that? Um, and my first thought was maybe I could use something like ChatGPT. Nowadays, ChatGPT is like a, you know, one size fits all solution, right? And so I tried to ask it this question here. I said, give me a 5 letter word for lies around lazily. So lies around lazily was the clue for the crossword, and it was 5 letters long. And it gave me the word lounges back, which clearly, if you count 1, 2, 3, 4, 5, 6, 7, that's not 5 letters long. So ChatGPT is not great at solving these things, unfortunately. So put a big red X on there. We're not going to be able to use ChatGPT to do this for us, unfortunately. But one alternative that I came up with was to create a database of common clues and solutions, right? So if you're not familiar, if you're not a frequent New York Times person, basically they like to reuse a lot of their clues, and sometimes they'll put like little twists on them, but they'll reuse a lot of the words. Sorry. Um, so I thought that might be a good approach to creating like a mini like a solver, right? So with that in mind, and then I'm still in the shower thinking about this. I was thinking, okay, I need some way to gather all of the clues and all of the answers from the mini, right? Like I could do it manually, like literally go onto the website and write down the word and the clue that corresponds to it, but that would take like ages, and I don't want to do that, right? And then I was thinking to myself, okay, maybe there is an API that I could use, right? And if you're not familiar, just a quick aside, an API is just a way to retrieve data from another source over the internet. Um, we have a big in-depth workshop on this very topic from last quarter in Stack School. I am not sure if it's on our website yet, the slides, I mean, and the recording, but I think it's in the Discord. If you dig around somewhere there, you can probably find it. But yeah, so just a quick example of like retrieving data from another source. I pulled up this like the classic example, my go-to with cat facts. So if I click on this link, this is an example of an API, right? I'm just getting some random cat fact from some other source over the internet, right? In this case, a cat uses, I don't know if you can see this very well. A cat uses its whiskers for measuring distances. The whiskers of a cat are capable of registering very small changes in air pressure. Wow, neat. Okay, so back to this. Yeah, so APIs are cool and they're very convenient because they allow us to get data that we might want. For example, maybe we could get the clues and the answers from the New York Times API if they had one. Unfortunately, they don't have one for the crossword in particular. They have a lot of APIs out there. For example, like the books API, the articles API, most popular, etc. But the crossword doesn't have one. So we have to settle for something else, which if you remember the name of the workshop, you probably can guess what it is. We need to scrape the website, right? And all scraping is, I'm not going to give you like a very technical answer. I'm just going to say it's just a way to automatically extract data from some websites using the browser, right? And you'll see an example of this. Okay, so here's the plan for the rest of the workshop. We're going to learn about scraping something called static sites, which we'll talk about. We're going to realize that that is not enough for our purposes for today. We're going to learn about scraping dynamic websites, in particular, the New York Times crossword. And then we're going to create a cool database of clues that we can search for. I'm not actually going to get to the solver. I encourage you to work on that yourself. It's a cool, fun little project you can put on your resume. Okay, cool. So before we get going, I did want to just show you what the end goal of today is. So first off, I have this video that I recorded, and this is a picture of, or a video of our scraper in action. So you're going to see, it looks like someone is just very quickly going through this website, and that is our scraper. It's literally automatically like interacting with the website for us, which is very cool. And this is exactly what we're going to be making later today. Okay. Oh, yeah, there we go. So here is the next part. This is our database, right? So it's going to allow us to, once we have gathered all the clues from our website here on the left, we can search through them using our database, which is very cool. Okay, hopefully that is clear. Man, it does not. Okay, there we go. Yeah, so, and again, before we get there, just some very, very quick background on HTML, which hopefully a lot of you have heard of already, but I just want to cover it briefly. Something that all websites have, it's going to define the content and the structure of our website for us, right? So if we go to some website that most of you are probably familiar with. For example, the CS32 website. This is project 3 for spring quarter. It's like an Indiana Jones spin-off type game, which is cool. But if we open up our, oh, sorry, I used the shortcut. I should probably actually, yeah. So if we go into our inspect, I right clicked on it. I clicked inspect. Can you see this okay? It's not too small, is it? Okay. Maybe I can just, ugh. Anyways, yeah, so here's our HTML for this page on the right here. If I click this thing and I click on this, you'll see that this part of our HTML corresponds to this part of our website, right? So you can see why HTML is important for web scraping, right? It allows us to, since it defines the content, we're probably going to want to dig through the HTML in order to get at the content, right? So say we wanted this paragraph, this opening paragraph for some reason, we would want to scrape this tag in particular. And you'll see what I mean when I say tag in a second. Yeah, so I think that is, leaking my, my stuff. Yeah. Okay, so that's just a brief little picture. Here's like a very simple HTML page. I just want to highlight a few things that are important, some terminology that we'll be digging into later. Yeah, so this is something called a tag. I mentioned this earlier. It's just a way to define some element. Like for example, a button here. It's just like with these like brackets and some text, we define some element on our page. These tags can also have something called an attribute, right? So we have two very important attributes, actually, class and ID. These are a way to, in web scraping, we can get at a certain element using this identifier. So ID, obviously an identifier. Class is also something that we can use as an identifier. All right. And then we also have the content, like I showed you. This is what we're actually interested in getting from our page, right? Okay. Yeah, so I'm going to hand it off to Shiyu to talk about scraping static sites. And let me stop sharing.
Thanks, Einar, for the paper introduction. Yeah, let me just share my screen real quick. All right, show. Yeah, so what I will be introducing is how to scrape static sites. So before we actually do anything, the first thing that we need to do is to set up the environment. So environmental setup sounds very scary, at least to me. So I would not want to do that under most circumstances if I can avoid it. But for this workshop, rest assured there isn't really much to do. All we really need to do is to download and install 2 Python libraries onto our computer. So the first one, and also the major one, is Beautiful Soup 4. Since we're going to use Beautiful Soup 4 for scraping. And basically what it does is that it extracts specific information from the HTML files, and it simplifies the process of navigating, searching, and modifying the contents of these files. And we will get deeper into this in the next slides. And another library that we will use, but is not as major, is not as important, is called requests. Basically what this library does is that it sends HTTP requests to a web server. Just a side note, libraries is just a set of tools that we can conveniently use in our programs without needing to write the code ourselves. So it's quite popular, it's quite convenient, everyone uses them, so that's great. And to download and install these libraries, all you need to do is to run this simple command in your command line or in your terminal, pip install request Beautiful Soup, and you can just copy paste this code and go to your terminal, which is what I will do right now. I have a terminal open here. Basically what I do is I'll just, pip install and copy over the rest. I'm not going to run it because obviously I have these libraries installed on my computer. But if you haven't, just make sure to install it. All right, so that's it. That's our environmental setup. That's very one of the easiest setups that I've ever done. So that's great. And yeah, so I've promised that we're going to talk more about Beautiful Soup 4. And this is one way to understand it. This is my way to understand it. Your, free to develop your own understanding of this library, but based on my own understanding, the HTML of a website is just like a soup of different ingredients. Like this soup over here, you have, carrots, you have other vegetables, you have, I guess, tomatoes. I'm not sure. But yeah, it's just a soup of a lot of different things. And what the library does is that it helps us make sense of the soup by allowing us to pick out and examine specific ingredients. For example, I am not a fan of carrots, so I would like to locate and retrieve the carrots if possible and leave everything else in the pot. After I locate the retrieve the carrots, I might do something with them. Most likely, I'll just get rid of them. No offense to carrot lovers. So in this case, the Beautiful Soup library is just like this magic filter that will filter out all the carrots for us from the soup, from this gigantic mixture of everything, and enable us to process with these carrots. So back to our web scraping scenario. Oh, okay, this is what I'm gonna do. I'm just gonna find all the carrots and get rid of them. So back to our web scraping scenario. If you're interested in, for example, extracting headlines from a news website, in this case, the HTML still is the soup, but the headlines are now the carrots. I would like to find all the headlines and probably do something with them. So similarly, Visual Soup can help you find all the elements labeled as headlines in the HTML, which makes it much easier to work with just the parts of the website you're interested in. I don't have to deal with, the actual content of the news. I don't have to deal with, all the irrelevant information on the news website. So I wouldn't, get lost in the rest of the HTML. That's something that's desirable. That's something we want. That's something that's very great. So this is the reason why we want to use this library. And there are other libraries that could, enable us to do similar things. But for this section of this workshop, we'll just be focusing on this specific library. All right, so that's the two libraries. And, we're now ready to get started to scrape. And we're all really ambitious. So we would really like to start scraping real world websites if we can, but that can be very complicated. For example, when I was, planning this workshop, I tried to, scrape this website that I use a lot daily. It's called My Anime List. It's basically just a anime website or anime information website. So the homepage looks something like this, which is honestly not super complicated. It does not have a lot of fancy layouts or animations. It's just a very simple header, sign up, and some general information about the website. So it should be really easy to scrape, or is it? Because I tried to download the HTML code for this website, and it turns out there are more than 4,000 lines of code, which is a complete disaster for me to read. And what's worse is that it has a very complicated HTML structure. What that means is that it has deeply nested sections. Imagine if you have to look at a nested for loop, that's, there are 5 layers of the for loop. I mean, that's the maximum that I can take. I cannot, understand possibly a 10 layers of for loop. So that is the same thing here. You cannot understand something that's nested for like over 10 or more layers. And also each layer is stacked upon each other, which makes it even harder to understand. And also there are some parameters, functions, and scripts that just simply does not make sense because I did not write the website. I don't know like what kind of functions that they developed when they were using the website, like the website developers. For example, over here, I have, a line called window mal GDPR cookie key equals to blah, blah, blah. I have no idea. I have zero knowledge what that means, which just complicates my understanding of this website. And something that's very unfortunate is that we cannot scrape a website if we don't understand its structure, which if you think about it, makes total sense because you cannot write a program about something that you understand either. All right, so instead of scraping a real world website, unfortunately, we're just going to start simple with a website that I built. So the website just looks like this. This is a anime website. This is a fan page for an anime that I like a lot recently. It's called Sousou no Frieren. So don't judge me on my coding skills. This is very simple. I probably spend no more than 30 minutes or like no more than 10 minutes coming up with this website. But yeah, I can actually just open it in my browser. Actually, I probably have it open already. Yeah. So if you take a look at this, it's very simple. It has, a title, it has some text, it has a section called description, a section called main characters, a gallery, and also a very simple and modest footer. And also we could take a look at the code that I actually wrote, which is over here. I have, a HTML page. I have the HTML code. This is the declaration. This is HTML, and I have the header section over here, which specifies the title of the web page. And I have the body section, and inside the body section, I have a header. That's basically just say welcome to the page, and a description section, which has a paragraph of the description of the anime. And I have main character section, same old. I have gallery. There are 2 images in a gallery. I will make sure to increase the number of pictures just because they're all adorable. But over here, I have one last section of the footer. Thank you for visiting. All right, so that is indeed very simple, very straightforward. Hopefully we can work with it. We will work with it. Yeah. So let's go back to the slide. All right. So just before we start working to scrape this website, we need to do some preparation. Like I said before, Beautiful Soup deals with a soup of stuff. So the first thing that we need to do is to prepare the soup. So to prepare the soup, there are a couple of just template code that we need to insert to prepare. And the first thing is just to import the library at the beginning of the Python script. You always import the library at the beginning, and you always do it first because you might forget about it if you do it later. So over here, we'll just do from BS4 import Beautiful Soup, just copy paste it in your code or your code file at the beginning, and it will work. It should be good. And the next thing that we need to do is to actually load the HTML file on your computer into your script. So over here, my file, the file that's over here that I just walked through is called freerand_fanpage.html. So I am just going to read that in using this piece of code over here. It's going to be with open this file, R encoding as file. I'll explain what these means in a second. And then after you've opened this file, you're just going to read this file, and you're going to store the result of this read into a variable called the HTML. So more about this line. So this line of code, you first passing the first argument, which is the name of the file. And the second argument, this is just a single character R. What it means is that it represents the mode in which the file is opened. Here, R stands for read, which means that this file is opened in read-only mode, and you won't able to write or execute this file, which makes total sense because we don't really want to change this HTML file. We don't want to run it or anything like that. We would just want to see what is in there, and we want to, extract some useful information from it. So read-only mode is the right mode for us. So we're using the character R over here. And as for this encoding, this basically just represents the encoding that's used to decode the file. And UTF-8 is a very common character encoding. So that's what we will use right now. UTF-8 will work for most circumstances, unless you have some, really special use cases. And then in that case, you could, try to search up what kind of encoding would work for your case. But for our purposes, UTF-8 would be enough. Yeah, so that's just some template code. And there is one more line of template code that we need to use. So we have, opened our file, we have imported our library, we're all ready. One last thing that we need to do is to create the soup object. So to do that, we will write this line. You can copy this line code in. This is called soup equals to Beautiful Soup HTML parser. So what this does is that this transforms the plain HTML content into a structured format that our library Beautiful Soup can easily navigate and manipulate. So if you remember, this HTML argument that we parse in right here is the variable where we store the results of our file read. And the second argument over here is called HTML parser. Basically, what it does is that it specifies the parser that Beautiful Soup should use to parse the HTML. And HTML parser is Python's built-in HTML parser, which is kind of repetitive, I guess. But it's useful for most cases. So we're going for like generality over here. So that's also what we're going to use. And if you don't really know what a parser is, basically it's like a language interpreter, but it's for computers. Just like people need to understand spoken or written language to make sense of it, parsers help computers understand the structure and the meaning of text-based data that will include code or documents, and also including our HTML page. So what it does is that its job is to read through the HTML code of a web page and make sense of its structure. More specifically, it will break down the HTML into a format that the computer can understand and work with. It also allows programs to navigate through the different elements of the web page. It allows the program to extract information or manipulate the data as we need. So it's really powerful. That basically includes everything that we want with a web scraping program. So our entire program to some extent is entirely based on this parser. We cannot do anything without it. Because without parsers, program would just see the HTML as a jumble of text and wouldn't know where one piece of information ends and another begins. So this is very confusing to our programs and to us, because we will see that the program will not be working. This is a diagram that illustrates this idea on the previous slide. So if you just feed the HTML page into your computer or into your program, it will not be happy about it because they don't understand. It just does not make sense to it. But if you first pass the HTML page and hand it over to a HTML parser, and it will parse the content, and then you give the parsed content to the computer or the program, it will be happy about it because now it knows every piece of information. It knows where it starts, where it ends, and it can do a lot of powerful things with it. All right, so that's for our HTML parser. As I just said, you can, we are using HTML parser over here, but you can also choose other options as well. So this is just a table of some common parsers that are being used, and also their advantages and disadvantages. So if you can see here, the advantages of the HTML parser is that it has a decent efficiency. It's not super fast. It's not blazingly fast, but it's acceptable. And also it's very lenient, which means that it works under most circumstances, and that's something we want. So this is why we chose HTML parser for this workshop, for this section. And there are other parsers available as well. They all have their different advantages and disadvantages. All right. So if you're interested, you could always look these up and see if they fit your use case. Cool. So now supposedly we have prepared our soup. We are ready to start cooking. And for this specific section of web scraping, I'm just gonna introduce a couple of methods or a couple of ideas that you could employ when you're doing web scraping. That will include find elements by HTML class name, by CSS class name, by CSS ID, by text content, and also a little bit of basic navigation inside your HTML code. And we will get to see what that means in a couple of minutes. Yeah. All right. So from now, I'm just going to switch to my code tab, which I have ready right here. So over here, I have, the HTML code that I wrote. We could always, revisit this code if we need to. And over here, I have, a piece of code that I've pre-written. If you can see that I have, all the code prepared already, but I'm just gonna walk through all of them while I'm, introducing these ideas. And so for this piece of HTML code, if you want to, work along, if you want to play with it, it's available in our GitHub repository. I don't think anyone has pasted the link in there. I can send the link right now. Okay, yeah. So if you follow this GitHub link, you will see this. You'll see the link to this HTML page, and you will also see the link to all of our demo. So yeah, you have like the answer to your midterm already. Anyways, so over here, you can see that we have all of our preparation code in here already. Import library, open the file, create the soup. Yay, we are done with our preparation. And we can just, the first thing that we can do is just to print out the soup and see, how it looks like, I guess. So we'll just do a very simple print soup. It's over here, and you can see that, hey, it's printed out, basically the HTML code that we've written. And that's not that cool because you see, if I want to get to see the HTML, I can just, switch to this code tab and it's there for me. Why would I need to do that? Yeah, that's not the most exciting part of this demo. So this is just, to demonstrate what kind of object or like how does soup look like internally. But we'll remove it. And right here, you can see that we have all these, H2 section, header, meta, head, HTML, these contents that I am totally not interested in. I just am interested in the text. I just want to read the text. I just want to see like what this is about. I am not interested in any of the formatting or any of the technical details. So one thing that I can do is I can get all the text from the page. So the way that I will do that is by calling this function get text on this object soup. And I will store the result in text and I'll print the text out and we can run it and see, what will happen. And we can run it. And all right, so we have a new piece of output and you can see over here, that's great. That's pretty, just the text and no annoying tags, no annoying technical code. It's just like the text of our web page. So that's pretty cool, but not the coolest thing on the earth. And we can do more with this later or like right now. All right, but that's how you can extract all the text from the web page. And I'm just going to comment this out so that for our later demo, you can see a clearer output without this whole, this entire text of our website. All right, so the first thing that I want to introduce is how you can find elements by HTML class name. So as Einar briefly introduced before, HTML class name is just this tag over here. So that will include, this div and this button over here. So so the way that we can do that is we can call another function. For example, say that I want to find the first H1 element in my HTML page. So if you actually take a look at the HTML page, you can see that, okay, here, this is not H1, this is not H1, these are not H1s. All right, here is our first H1 element. So basically, I want to find, the title of our web page. So the way how we can do that is we can call this function called find. And this is over here. You can call find H1 on the soup object. Basically, it will find the first H1 tag in the document and we'll print it out. We can run this. And so right here, you can see our output over here. Welcome to 搜索呢4点fan page with the H1 tag with the brackets surrounding the text. And there's the same problem that I am not interested in this H1 tag whatsoever. I am only interested in the text content. So what I will do is that I will, add one more layer of processing on top of that soup find. What I will do is that I will extract the text out of this element by using this dot text attribute. So we can run this program again to see its output. And this is totally amazing. We have our text of the H1 tag, but we don't have the tags anymore. That might be a little bit confusing, but in its very essence, we just extract the text that we are interested in, and we get rid of other distracting code and everything else. All right, so yeah, that's how you can find elements by HTML class name. But if you're careful enough, you would notice that my phrasing is a little bit weird so far because I have been stressing that it only finds the first tag in the document without, finding all of them, because there is a separate method to find all of them. For example, over here, let's say that, hey, I have a section of main characters over here, And I am now interested in scraping all the information about, all of the main characters. And if you closely observe the HTML code, you will see that all the main characters, they're listed in an unordered list, and each character is surrounded by this bracket or by this tag called li, which stands for list item. And so basically what we want is that we want to extract all the elements that has the li tag. But we cannot do it with .find because it only finds us one element with that tag. So what we will do is that we will use another method. We'll use another function called find_all. And we pass in, li, because we're interested in li. And we store the results in character elements. And then we loop through our results for each character element. And the results, we will print out the elements. Of course, we're still only interested in the text. So we will use the .text attribute to extract the text without tags. All right, let me comment this out. All right, so let's run it. And you can see here, voila, we have our list of main characters, which is amazing. Yeah, so this is how you can find the tags, find the contents by HTML tags in your document. But just one last thing to mention is that over here, I have introduced two methods. One is to find the first one, and one is to find, all of them. What if I just want to find not one of them, not all of them? What if I just want to find, two of them? For example, I am only interested in the first two characters in my website. Like, I am not interested in the rest of the characters. They don't mean anything to me. They don't matter to me. In this case, you can pass in a separate parameter. Over here, you can see that you can use the same old function find all, but this time you'll add a separate limit equals to 2. That means that this code finds the first two li tags. Maybe there are more, doesn't care, doesn't matter. We're only interested in the first two. All right, you can try to run it if you're interested, but you probably have to print out the results to see like what's going on. So if you're interested, you can just play around with the code. That's in our GitHub repository. All right, I'm just comment this out. So that's basically just our first, section, finding elements by HTML class name. I'm going to go a little bit, faster for the other sections, just because, now we are familiar with how this works in general. So the next section is going to be finding elements by CSS class name. We'll go back to this page again. The CSS tag, the CSS class name is different from the HTML class name. Over here, the HTML class name is this div, but the CSS class name is this class equals to yo. So that's different things, and we need different functions to filter these different attributes or these different identities or characteristics of our elements. All right, so in order to do that, we will actually not use, we will actually use the same function, but we will have some different parameters. So I just said that we're going to use some different functions. That was wrong. We're going to use the same function. So over here, if we're interested in finding all the elements with the class some styling, we can take a look at our HTML code again. So I'm trying to find, all right, this is the element that has, the class some styling, and I am interested in extracting this piece of element. So what I will do is that I will use the find all function still, and I will pass in this weird kind of code, class underscore equals to some styling. If you use class equals understyling, there is a possibility, there's a chance that it might not work just because it's how it's dictated in its documentation. And I think there is some kind of conflict if you just use class equals without the underscore. But just to make sure that it works, make sure to add this underscore. And basically what it does is that it finds all the elements with the class name called some styling, and it printed that. All right, so let's run it and see what happens. All right, so yeah, I actually forgot that there are more than this image that uses this class. There is a paragraph that uses this class, there is a h2 header that uses this class. So since we're using find all, this returns all the elements that's using this class. So that's the desired behavior indeed. And since we're printing them out without the text, it's preserving, all of the code, all of the tags, and maybe we don't want that. In that case, you just use .text. All right, so that's by CSS class name. And also over here, you can see that aside from class name, we also have IDs. So we can also, filter by ID. To do that, we'll just still use the same old function find, but this time you'll pass in the ID. Over here, I have, an ID called official link. There is no underscore behind this ID. Don't ask me why there is no underscore here. It's just how it's set up. I am not one of the developers for this library, so I wouldn't know. But ideally, if you run this code, it will find the element with the ID official link in this HTML document, and it will print it out. So let's just run it and see if it actually works as intended. All right, so pretty cool. Over here, it's returning the element that has the ID official link in here. So yeah, it's working as intended. And if you look at our code, you scroll through our code, this is indeed the only element that has this ID in our document. So yeah, it's working as intended. So that's great. All right. So that's our second section, finding elements by CSS class name and ID. But perhaps there is one very important function or one important functionality that you would want in this type of program, that is finding elements by text content. It's basically just like you're reading through a PDF file and you want to Control or Command F to find some text that you're looking for. And to do that, we will still use our find function in our scraping script. But in this case, we will have different parameters that we pass in. Over here, say that I am interested in finding the h2 tag that contains the exact text description. So over here, you can see that over here, I have a section, and this is the header description that I am interested in finding. And to do that, I'll just pass in another parameter called string equals to description, and that should do the trick. All right, so I am not going to print out the results, but just trust me that it works. It's pretty straightforward, so yeah, it should work. I don't see any reason that it would not work. Anyways, so that's finding elements by text content, fairly straightforward. And one last thing that I would like to introduce is how you could sometimes navigate through the entire document. You could, for example, go up and down, go back and forth, probably not left and right, but maybe you could do that. I'm not sure. But let's say that here I have found my, description header. But I would like to just go one level or one tag down to description. I would like to locate the P paragraph. This is the paragraph of my actual description. I would like to find it. I would like to scrape it. Of course, we could just, find all the paragraph tags, or we could also just search the text, but I don't want to do that. I just want to, is there a way for me to hop from this tag over here to the next tag over here? So actually there is. The way that we will do that is we will run this new function. Hooray, we finally have a new function. We will call this find next function on the descriptor heading. So inside the find next, I will find the next paragraph element. So I will pass in the p tag in here, and I'll pass this in, and I will print out the results with only the text segment. I will not be interested in the tags. So if I try to run it, you will see that, hey, it's providing me with the description of the anime. So that's indeed what we wanted. And also, aside from going to the next element, you could also go to the previous element, which you will where you will use pretty self-explanatory, the find previous function. And you will also just same, I will print out the result with the text attribute. And if we run it, And you can see that here, this is next element, and this is the previous element of description. You can go back to our code page, and you can see that here is description, and the previous p tag is indeed over here. This page is dedicated to all fans, and the next element is indeed this piece of long description over here. All right, so yeah, that's basically what I want to introduce about web scraping in Beautiful Soup. And there is just one last thing that I would like to add. This is not, related to our major discussion over here, but I would just, like to add to our discussion. Over here, when I was talking about, how to prepare the soup, I said that you need to load an HTML file on your computer into your script with this, file, or with this code over here. But what if I just don't have the HTML file? What if I just have this URL called ucla.edu that I would like to scrape from, and I just don't have the file on my computer? Does that mean that I would not be able to scrape? Of course not, because we have this additional library that we installed. Or yeah, I will talk about that in a moment. But what if we don't have the HTML file locally? The answer is we can ask the website for it. More precisely, we will fetch the HTML content from a website by sending HTTP requests to that site, and then use Beautiful Soup to parse this content. So over here, basically, I am asking the website for the HTML, and ideally, the website should be giving me whatever I want. So about HTTP requests, they're basically just messages that's sent between your web browser or application and the web server. So it's basically the way that your computer asks for and receives web pages, images, files, and other data from the internet. I will not, talk more about this concept because it's not super relevant to our workshop. But if you're interested, you can always search it up, and you could always go back to our previous workshops that's covering this kind of concepts. So to do this kind of asking for web page thing, we can use the request library. Basically, what we will do is that we will import the library at the beginning of the Python script. Same old, you always import the library first. And then you just copy over this kind of code into your file before you start, dealing with everything that I just introduced. So you have like an URL variable. You have this request.get URL. You have page.content. Everything over here, I am not going to go too deep into it because it's not super relevant. But if you have questions about it, just feel free to message us in the Discord, or just send a message in the Discord, or private message me. And I will be happy to go over this code for you. All right, so just a little bit of description. This line of code, this line sends a GET request to the URL over here, and the service response to this request is stored in a page variable. And this line basically uses the .content attribute to extract the content of the response, which basically is the HTML of the web page that we wanted. So over here, this is the final line of code. This is soup equals to Beautiful Soup. We are creating a soup object. And once you have this soup object created, everything beneath everything after that will be exactly the same as what we have done here. You just do whatever thing you wanted to do with this web page, and everything else is the same. So that is one way how you could, have the HTML file on your computer. The other way, which is more straightforward and less technically advanced, is you could just go to a web page. Let's see, we can just go to the web page, and you can use shortcut Command F or Command S or Control S, which will basically just use this save functionality in your browser, and you can just save it in HTML format. And if you save it, you have the HTML code, which is very simple, very straightforward. And if you open it, you will see basically the same page as the one that I've opened before. So yeah, that's another way to get around this problem. Yeah, so that's basically what I want to introduce for static website scraping, and I will now pass on to Einar to introduce dynamic sites, because that's also something that's vital within web scraping, because you cannot do everything with what I just introduced. I'll stop sharing right now. And all right.
All right, cool. So before we go on, I do want to acknowledge that it's been a little over an hour. So if you're starting to feel the Zoom fatigue, I understand. I recommend getting up, do some jumping jacks, turn your camera off. Also, what helps me a lot is to look at something like 10 or 20 feet away just to like rest your eyes a little bit. So recommend that. Unfortunately, due to time constraints, we're not going to take a break. But yeah, you can just do it while I'm talking and I won't mind. Don't worry. Yeah, so talking about dynamic websites. So Beautiful Soup is great, but unfortunately it has a limitation that it is restricted to static sites, right? So some of you might be like, what exactly is a dynamic website? What is a static site? So what makes a site dynamic is that, quite explanatorily by the name, the content of the website is dynamic, which means that not all users are going to see the same thing, right? So an example is something like YouTube. If you log into YouTube, one person will see something completely different than another person, like different videos. Another example, which is why we're even talking about dynamic sites right now, is Down for a Cross, which is the website that we will be scraping in a little bit in order to get all of our clues and our answers for the database, right? So since content is dynamically loaded in a dynamic website, it is a bit harder for us to scrape because we have to actually simulate the user interactions on that website, right? So we're gonna have to use something. Beautiful Soup, we love it, but we can't use it in this case. We have to use Selenium, right? So this is another web scraping website. It's good to have both in your tool belt because Selenium can be a bit overkill if you have like a simple site like the CS32 website, for example. But in our case today, we have to whip it out. If you haven't installed it yet, if you've never used it, you can do that with pip install Selenium the same way as you did with Beautiful Soup. Okay, cool. So your first Selenium script, this is literally, I just want to talk about, they give an example on their website of the first thing that they expect you, or that you should write for your intro to Selenium. So I'm just going to pull that up. I just copy pasted it. I encourage you to do the same if you're following along. If you're not, then that is fine too. But I'm just going to take a look at it and try to guess what it does. So you can see the VS Code, right? Yes. Okay. Cool. So yeah, you saw I just copy pasted this over. Actually, my first time doing this, I did the exact same thing, and I don't expect anyone to like really memorize all of these steps. It's literally like there for your reference. So why would you do that? So first up here, we're just importing all the necessary imports, right? Then we are creating some kind of Chrome driver. I'm not sure exactly what that means. It doesn't really matter to us right now. And then it seems like we're opening some website, right? So if I click on this website, let's see what it looks like on the left here. It's this web form that Selenium themselves, the people behind Selenium, made, right? And it has a bunch of different fields on it. I think it might be helpful to open up the developer panel here so that we can take a look at what each of these things are called. So this is our H1. This is like some text input. It's called my text. And so yeah, you can see it's just probably a way for us to mess around in Selenium, which is exactly right. And then further on in this demo, I'm just gonna minimize this a little bit. In this demo, we get our title. So it might not be clear exactly what this is, but I'm just gonna tell you, it's just literally getting this title up here. So if I print, and I'll just run it all at the end. Actually, no, I'll just run it now. Why not? Python demo.py. It's going to take a second to load because Selenium is quite slow. That is another reason why it's overkill and you might not want to use it in all cases. but hopefully it loads up here. Okay, there we go. So you can see it opens this page. And then, yeah, then it closed immediately. So it got the web form from our page, which is great. And then it does this thing, which it says it's implicitly waiting. I don't know what that means. We'll go over it in a little bit. And then it's finding an element, right? So this is similar to what we saw in the Beautiful Soup demo. We're literally just going to find an element by some name, and that name is my text. So let's see if we can find that in our page here. It looks like it is this. So it's going to be this text input. So this text box, when we run the script, is going to refer to this text input, right? And then similarly, down here, we have another find element, which is going to be the submit button. You might guess that that is this button down here, and you'd be correct, right? Cool. And then down here, we are sending some keys to this text box, which I think pretty self-explanatory. We're literally just going to send some keys into the text box. In this case, we're going to type in Selenium. I'm not going to type it all out because I'm a bad typer. Yeah. So we're just going to send Selenium into this text box. And then .click, we're probably going to click the button to submit. So I am just going to do this so you can actually see the result. This message isn't there yet, but you can imagine that it might pop up after we click submit, right? Okay. So blink and you might miss it, but it did pop up and it did do that thing that we requested it to do. So if I'm just going to put some random stuff in there. If I click submit, you can see it pulls up this second page, and it gets this text, right? So this message, the ID, we're finding some element by an ID, which is message, and it gets this and then it prints it, which is great, okay? So very cool, very neat. That's our first foray into Selenium. Yeah, I'm just gonna zoom by this. Originally, since this was gonna be in person, I was gonna have you guys go off on your own and attempt to tweak this script a little bit in a, decently non-trivial way. But since we're on Zoom, I'm just going to do it myself. And all I'm going to do is I'm going to enter the password 12345 exclamation mark underscore exclamation mark into the password field and then click submit. Okay. So first off, in order to do this, I probably need to know what this password, how to identify this password field here. So if I look at it, you can see it has the class form control. That might not be unique. It also has the name my password. So I think that is probably our best bet here is to just use that. I'm just going to modify this a little bit to get that password text box. So if I replace this value, we're finding the element by some name, right? That name is this attribute. If I replace that with my password, then this text box should now represent this password, right? And then I can type in 1, 2, 3, 4, 5, and then that little face that I made. And I can type that in, and then it should do the same thing. Unfortunately, I doubt you'll be able to see it, especially over Zoom, because they don't send all the frames. But it would be neat if you're doing it on your own, wouldn't it? Yeah, there you go. So going back into this, you probably noticed this implicitly wait thing that came up in our code right over here. And you might be wondering what that is. And I will get into it right now. So it's an example of something called a waiting strategy. Okay, so what exactly is that? In Selenium, since we are literally simulating all of the interactions on our web page, we need to wait or make sure that they're available to us, right? Because websites take time to load, right? So we can't click on a button if it hasn't loaded in yet, right? So think, for example, if I click submit and then it takes some time for this second page to load, we can't access this page if it hasn't loaded yet. So we need to wait for it to do that, right? We have a couple ways of doing this within the context of Selenium. One is just a vanilla Python method called time.sleep, which allows us to sleep for some particular number of seconds. Unfortunately, this is super unreliable and not the way to go because we have no way of knowing how long it's going to take for something to load in our scraping thing, right? For example, something at one point might take 1 second to load, like really quick on someone's like really fast gigabit Wi-Fi, but on someone else's like lower tier Wi-Fi, it might take much longer, like 10 seconds. So not the best approach here. We also have implicitly wait, like we saw just now, which attempts to automatically figure out the wait time. Unfortunately, this is a global application. So it's much less granular, and in general, Selenium themselves claim that it's not the best approach and usually not a great waiting strategy. A bit better is something called an explicit wait, and I'll talk about that. So with explicit waits, we are literally, for each element that we want to wait for, we are saying, please don't move on to the next line of code until this condition is met, right? So these are generally considered to be a little bit more reliable, and I'll show a bunch of examples as we go onward. I don't want to explain this in depth because it's boring, so let's just let's just show an example in our code. So what I'm going to do is instead of having this code implicitly wait, I'm going to get rid of this. I am going to just add an explicit wait. So I prepared this little snippet, which looks a lot like what we have to type in, which is great. I'm just going to copy paste these imports because I don't remember them. I'll be very honest with you. And I need to copy paste this wait. Yeah, so I'll put this down here. So this is just establishing our wait, or our web driver that allows us to wait. And notice that I put a timeout of 15 seconds. That's probably too much for this case, actually, but you can mess around with it for your purposes whenever you want. And then we also have this function down here, which is just waiting until, and then this is a stand-in for some condition. So in this case, the presence of some element has been located. Yeah, so I'm just going to type that in or copy paste it. And I will put it down here. I want to wait until this message has appeared, right? So I'm probably going to just get this and copy paste it into there. Okay. Wait, one sec. Yeah. Okay. Yeah, there we go. GitHub Copilot to the rescue. Okay. Oh, whoops. Now we go. Okay. So I just modified my thing to use explicit wait, and it worked, and it's wonderful, and it's great. So very cool. We're going to want to use explicit waits for the rest of our time here together. Yeah. Okay, so with that out of the way, that was a little primer. So time for the real deal, what you all came here for. Well, I don't know if you did come here for this, but this is what I came here for because I thought it was really fun and cool. Yeah, so we're going to be actually scraping the New York Times now. So the first step, as with any web scraping journey, is to take a look at the website itself. So I have it pulled up over here. I'm going to get rid of this. I have it pulled up. This is what it looks like. Unfortunately, we can't use the actual New York Times website because it costs money, and I don't want you all to have to pay if you want to do this on your own. So this is a free alternative, and it's pretty good. It has all the New York Times websites loaded onto it, or all the New York Times crosswords loaded onto it, which is great. So if we just look up New York Times here, we can see that there's like a whole bunch. And if we click on one, then it pulls up this game, and we can take a look at, We have this clue, uttered utterance, which I don't know the answer to. Actually, I already did this. I did this earlier. This one is mallard. I forget what the answer to this one was. But anyways, that's the first step, is to to look at the website, right? As a quick note, this takes a lot of trial and error, right? So it's best if you come up with a plan beforehand. You're probably gonna have to tweak that plan as you go. But you know, yeah, I just wanted to make a note of that. I also encourage you to use Copilot, because why bog yourself down in syntax? The syntax can be a little funky, a little weird sometimes. So if you don't have to do that, then why would you do that? And also, I made a note of this. I forgot that I added this. Originally, we're going to have you do all this on your own, working through some checkpoints, and we're going to walk around to help. But since we're on Zoom, we can't really do that. So instead, I will just be showing you an incremental approach. I'm not going to actually type in all the code, because I don't want you to have to watch me type in 100 lines of code. So yeah, but here's my plan. So I think if I take a look at this this website here, I probably want to start off on this page, right? Since it has all the New York Times crosswords available to me, and then I can like iterate throughout each of these, you know, each of these, and click on them, and then do my thing within them, and collect all the clues and the answers, right? So if I take a look at the structure of this website here, you'll see somewhere inside one of these, if I can find it. Oh yeah, here it is. There's an A tag, and an A tag, if you're not familiar, is like a link to another page. In this case, it'll link us to open the crossword itself, right? So we're probably going to want to open that up and click on it. Okay. Then we're going to want to, once we click on that, once it's loaded, then we're going to want to do our thing and then go back. I think a good place to start is just to do that one thing, because, like I said, this is very trial and error. It's best, as it is with anything, honestly, to incrementally approach it, right? So I have this written out. I hope you can forgive me for that, because I just did not want to type it all out. But yeah, so I'll just walk through it very quickly. What this is doing is basically exactly what I just said. It's importing all my stuff, setting up some general Selenium stuff, opening up this website, which is this website that I have on the left here. And then it's going to get all of these crossword entries, right? So if I look at this right here, if I look at this, you can see that each of these has the class entry container. So if I if I try to find all these elements, it'll give me a list of all of these divs that I can then iterate through, right? And you'll notice that I'm also waiting until those appear, because if they're not there yet, then I can't exactly click on them, right? So that's why I'm doing that. Then you can see this is a for loop. I'm iterating over all the entries, and then I click. I find the A tag within this entry, and then I click on it. I wait for the page to load, because it takes a second, right? And then I just go back. Also, it's neat that it saves my progress. I like that. Yeah, so it goes back to the previous page, right? So I'll just run this just to show you and prove to you that it does indeed work. So this is the first step in the demo. So it pulls this up, it loads, and then it just goes crazy, traveling throughout each of these crosswords, which is great. It's kind of mesmerizing. Yeah, I'll close that. Yeah, so that's the first step, which is great. And also, I just want to say, I encourage you to go through and do this later on your own. I know I'm just kind of zooming through it, so you probably can't like type it very quickly right now as I'm going, but yeah. Okay, so then now that I've done that, for each crossword page, I want to enter the list view. And I'll show you what exactly I mean by that. So if I enter this first crossword here, we have something called the list view. If I click on this button right here, it'll change the way, it'll change the appearance of our crossword into a much more, I'll just say, web scraper friendly format, right? So rather than having to like iterate through all of these and then like try to find it in the crossword somehow, I can literally just go throughout all of these divs. So if I, oh, whoops. Man, I'm kind of losing my voice. Yeah, so you can see it's much more easy to just iterate through each of these because they're just divs that are in sequence, right? So I'm going to want to do that. That's the next step. If I click on here, luckily, I have already done this. I just added this little chunk of code right here. So I'm waiting for the way I determined what this class name was is I clicked on this, and I will expand this out. And then I saw that it had this class name, right? And so I just typed it in right here. Okay, so I'm waiting until that appears. And then I'm going to find that element, and then I'm going to click on it, right? So pretty self-explanatory. And I will run this to prove that it does indeed work. And while I'm running it, I'm going to drink some water. So if you look, it kind of flashes into the list view, but you can see that it does work. Okay, cool. So I'll close that. The next step is to go on and reveal the answers because I can't gather the answers if they're not there, right? So there is luckily in Down for a Cross a button that you can use to reveal all the answers. You're gonna have to click reveal, then puzzle, and then it pops up this like, are you sure? And click OK. So this is a little bit more involved than turning on list view, but not too bad. If I open up our third step here, you can see I added this code. And basically all this does is exactly what I've just showed you, right? So it'll look for the reveal button, which I need to press play again if I want to see it. Yeah, so it'll look for this reveal button. The class of this reveal button is reveal. So it'll find it and then it'll click on it. And then that will trigger this little modal thing to pop up. Then I look for the class of this puzzle. And then I click on that. And then the confirm thing pops up. And I click on that. And then finally it is revealed, right? So you can see as we're going through this, how this might get, or it might seem to get a little tedious because we have to like literally do each thing like repeatedly and just really make sure that we're not using the wrong class names because it's a very easy mistake to make. But it's not too bad. So we ran this. You can see it is now revealing the answers for each one, which is very cool. Okay. Okay, the next step is to, now that we have the answers and the clues, is to actually iterate over the clues and the answers and set up our data structure to actually store this, right? So just looking at this, you can see just getting the clue itself isn't too bad. It's just a span that we have right here. A span is just a tag used to store some text, like inline text usually. And so we can just find that span, and then that'll be our clue. The answer itself is a little bit more involved because it's within this like table type thing, right? So we have a bunch of cells, and all of these cells have values, and that's where our answers actually are. So what we're gonna have to do is iterate through each of these cells retrieve the letter, and then combine those into a single string, right? And that's, it's a little tricky. It's not too important because the focus here, right, is to is scraping, not like how to join together a list of stuff. But that is here in this this fourth demo, right? So you can see I iterate through all of the clues. Each of the clues is in a div that has this class name. Then I get the clue itself by getting the text from each of those spans. And then I get the answer by iterating over each of the cells, right? I also, oh yeah, I forgot to say, I created this data structure. It's called the default dictionary. Don't worry about it too much if you're not familiar. It's really not the focus of our workshop here. It's just if this makes sense to you, then great. If not, don't worry about it. But it's just a series of key value pairs, right? Okay. So yeah, so let's run this. You'll see that it'll take a little bit longer for us because it's actually going through each of the clues and writing them down. So it pauses a bit as it writes down the clues and the answers. And it's storing them in this dictionary that we created. Okay. Yeah, it takes a bit, so I'm not gonna bore you with that. But luckily, we're almost done. We have one last step, which is to write to our file, right? So we want to write to some JSON file so that we can, maintain our database over time, and then potentially search within it, right? So the way to do that in Python, not too bad. We can just use this with open, and we can, first load the database if it exists, and then write to it on each iteration as we progress through our web page, right? So if I run this, okay, and then you'll see this database.json has a bunch of stuff in it. The format, not too important for our purposes right now, but it creates, it creates this database for us, and we can then search through it to find our clues, which is great and very important for our next step. Yeah, so you can see it just added to the database there. Okay, cool. So I think that is whoops. I think that's pretty much it. You can find the code on the slides if you click on this image here. It's within the web scraping folder, within the Selenium folder. All the code is there. If you have any questions, feel free to ask. More than happy to help you. I do recognize that we went through it a bit quickly, and you're not going to be experts on Selenium just by seeing me explain the code, right? So yeah, encourage you to look at that. Okay, so now all we need to do is just leave that running for a while, and then we have our database. And I already did that for a little bit. It has a bunch of clues and answers that we can search through, which is great. Yeah, so now we need to actually create our program that allows us to search, right? So that is the next step, and I'm going to let Hazel talk about that.
Yeah, just let me share my screen first. Wait, can you guys see it?
I can't. I don't know if that's just me.
Wait, let me try again. It keeps pausing. Sorry, give me a second. Yeah. Can you guys see it now? Okay, good. Yeah, so now we can move on to creating a searchable database where we can kind of look through all the clues that we have scraped in the previous step and just make it so that we can actually use the information that we have gathered. So now how we'll do this is we can utilize Python and specifically the pandas library when it comes to doing this. Okay. Yeah. So what exactly is Pandas? So Pandas is a software library written for the Python programming language for data analysis, and it offers data structures and operations for data manipulation, such as slicing, grouping, merging, and reshaping data, input and output tools, handling missing data, such as missing values or dropping incomplete rows or columns, as well as the time series functionality, which includes date range generation, shifting, and frequency conversion. So at its core, Pandas provides two main data structures. So this would be a series and a data frame. So a data frame is essentially a two-dimensional tabular data structure which resembles a spreadsheet or like a SQL table. So this consists of of rows and columns where each column can have a different data type. And the data frame will be better at organizing and analyzing structured data. And this will make it more appropriate for tasks like data cleaning, exploration, and transformation. Sorry, give me a second. Yeah, so in comparison, a series is a one-dimensional um array with flexible index capabilities, and it can hold various data types, including integers, floats, strings, and other Python objects. So through its labeled index, it will be easier to use a series to kind of access and manipulate data within, and it just makes accessing data more intuitive. So before we start creating a way to search through our crossword clues and solutions, we have to consider which data structures would be more appropriate for this task. So typically for crossword, the clues and solutions will be structured in like a dictionary where the keys will represent the words or the solutions and the values will be the clues which are associated with each solution. So this structure will allow us to have more easy access to both the clues and the solutions in each pair of the crossword puzzle. So with this in mind, we would need two separate columns. So since we need two columns, a two-dimensional data frame would be much more appropriate than a series when it comes to organizing the data that we have just scraped. So before we begin creating anything, we need to start by importing the libraries that we are going to be using. So what we need to import for this specific scenario would be the pandas library as well as JSON, since the data that we have just scraped is stored in a JSON file. Next, we need to load the clues data from the JSON file. So when we load the data, we can actually load various file formats into the pandas data frame, such as CSV, Excel, JSON, and a SQL database, and just many more. So these are just some examples. So to do this, we can use the JSON.load function, which will allow the JSON data from the file. So what this function does is that it reads the JSON data from the file and it parses it into the Python object. So for this, we will be loading the data into a Python dictionary, and this dictionary would contain the key which corresponds to the words and the values which contains the list of clues associated with each word. So next, once the data is loaded into a dictionary, we can create a data frame from it. So for this, we'll be using the pd.dataframe constructor provided by the pandas library. So right now, our JSON object contains a dictionary where each key is a word of interest, which would be a portion of the hint, and each value is a list of full hints associated with our word. So our goal is to convert this dictionary into a tabular format where each row represents a hint and along with its corresponding word and answer. So we can do this by iterating through the dictionary and extracting the relevant information. The outer loop so for the code sample that I put at the bottom, the outer loop will iterate through each word of interest in the for word here, and then while the inner loop would iterate through each full hint associated with the word. So that would be in the for hint in hints. Yeah. So for each hint associated with a word of interest, a tuple would be created, and this tuple will contain 3 elements: hint 0, word, and hint 1. So what exactly is hint 0, word, and hint 1? So if we were to look at the data that we have just scraped from the internet, what we'll get is that we'll get a full hint. So for this example, the full hint would be fly buzzing around the house example. And then the solution would be pass. So the word in hint 0 in this case would refer to the entire hint, which would be fly buzzing around the house. And then for word, it will represent the key or the word of interest that is extracted from the outer loop. So for this specific example, that would be fly. And then for hint 1, this would represent the second element of the hint tuple, which would be our solution. So in this context, it will be pass. So this is just one example of all of the data we have scraped. So once you've iterated through all of the hints for all of the words in our data set, we will end up with a list of all of these tuples. And finally, we can pass this list into the pandas data frame constructor, where we can specify the column names. So for the purpose of this, since we would want to be able to search for our answers based on specific words, we can put our columns as hint, which would contain the entire hint, word, which will contain a specific word of interest from the hint, and answer, which will be the solution which is associated with this hint. So once we have got that down, we can move on and create a function which will allow us to provide inputs, and which we will then use to filter through our database and just provide solutions of interest which the user might be looking for. So how we do this is we need to know what the user is looking for first. So we will need to prompt the user for some input, which we can use to search through the database. So we think about how we go about solving a crossword puzzle. What information we usually have is, firstly, the given clue, the number of letters in that word, and also possibly some letters or characters which are in the word if we have solved other parts of the crossword puzzle. So we want to allow the user to provide all of this information, which we will then use to filter through the database and only return potential solutions. So to do this, we'll use the input function to prompt the user for input. So within the parentheses of the input function, we'll be able to add details of the information we want the user to input in double quotations. So this will be printed out to the user, which then allows them to kind of know what they need to enter in that moment. So as we're doing this, I think we also have to remember to use the to lower method to ensure that all the input provided by the user is going to be converted to lowercase. So this will help us to ensure that there's some consistency in comparison, such that if we need to perform so that we can perform case insensitive matching when we are filtering through the database using the input hint and solution letters. So it also helps us to be careful to avoid case sensitivity issues, since users might not always input text consistently in terms of the whether it's upper or lowercase. So by converting everything to lowercase, we just make it easier and it's just more forgiving when we continue with the rest of our program, just to prevent any future mistakes. So I think one big thing of why this database works would be why being able to create a database from past clues works is because crossword puzzles generally have really similar clues and solutions, so we are able to match that up. However, I think the reality is it's not all of the clues will be matching like word for word to each other. So what we need to do is make sure that our database will be able to search through all of the hints and solutions based on maybe keywords and not just like the entire chunk of a hint. So in order to do that, we need to split up the input hint which we have just prompted the user to enter. So this will help give us more flexibility in order of like the order of the words in the hint, and also the usage of also in terms of how we use our database. So in order to split up our input hint, we can use the split function, which is a string method that splits the input hint into a list of words based on the white space by default. So for here, what I've done is I first changed everything to lower, and then again, just for security, and then I split up each chunk which the user has entered to the input using the split function. So this just helps us separate up our hints into individual words that we can use to compare with the hints in our database. So now that we have all of our hints, our input in individual words, what we need to do is use this input to filter our data frame. So as we mentioned before, we want to filter our data frame based on the hint words which was inputted, the solution length, and any potential solution letters. So this allows us to retrieve only the relevant clues and solutions which the user might be interested in, and it involves matching the hint, solution length, and specific characters in the solution using Boolean indexing. So what exactly is Boolean indexing? Boolean indexing is a technique used with pandas data frames to select specific rows or columns based on a condition. It then leverages Boolean expressions, which are true or false statements, to filter the data. So to filter the data based on words of interest, we want to loop through each word given in the output and filter the data frame to ensure that only rows where the hint column contains the word of interest which the user has inputted will be left. Next, we'll filter based on the solution length and letters. So if the code filters the data frame to only include rows where the length provided is equal to the characters provided in the input. Okay, wait, let me just rephrase that. So what we want to do is write a code that filters the data frame such that it will only include rows where the length that the user provided would be equal to the length of the solution which is associated with that row in the data frame. So we'll repeat that for the solution letters where only rows where the solution contains a specific letters which was provided will be included into this filtered data frames as well. So this is done using the .apply method along with a lambda function. So after applying all of the filters, the filtered data frame will only contain rows which from the original data frame which has everything that matches the user specific input criteria. And then this filtered data frame we can use for further analysis, and then further on we can display it to the user as search results. Oh, yeah. So this is how we can filter our data frame. So first we initialize our filtered data frame to our initial data frame, and then we go through each we filter it 3 times based on the hint provided, the solution length, and as well as the solution letters. So to prevent duplicate solutions from being displayed in our search results, we also want to keep track of unique solutions. So for this, we'll use a set called unique solutions, which will be used to store only the unique solutions encountered during the filtering process. So the purpose of this is to ensure that each solution is only printed once. Since our data is organized based on specific words in the entire hint, that hint and its associated solution will appear multiple times. So by using our unique solutions, it ensures that even if we search using multiple words of the same hint, which is associated with the same solution, it will only be printed out once when the user prompts it, so that the user doesn't have to scroll through like multiple versions of the exact same hint and solution. So yeah, so this just prevents duplicate solutions from being displayed in the final output, which will just be more useful for the user. So not only does this help prevent duplicates, but it also can help to promote efficiency by ensuring efficient duplicate checking, which will just help to which would have a constant average time complexity and will just make it more efficient. So after this, we're basically done with most of the functionality of the database. So all we have to do is just add the final details to ensure that it can work as we intended by making sure it prints the filtered data frame accurately. So how we do this is we make sure that the filtered data frame, that if the filtered data frame is empty and contains nothing, then the function will just return and maybe print out some notification that indicates to the user that no solutions have been found. However, if the data frame is not empty, this means that some matches have been found based on the user's criteria. So we'll then need to print out each unique clue and solution pair. And we can print out so we can do this by printing out all of the solutions inside the unique data set. And that's basically it. So now we can search through the clues. We can search through the solutions by using input clues through the command line in order to find potential solutions through keywords, as well as through solution sets and possible letters. So yeah, now we can move on to kind of going through the code and in more detail and just creating this entire file. So yeah, okay. So here we can create a new file, which I would just call unsearch.py, which we can then use. Oh, okay, sorry. I'll just, yeah, which we can then use to create this entire data frame that we can search through. So to begin, we need to start by importing the necessary library. So as I said, we need to import pandas and also JSON, since we're reading in a JSON file. So I think just to standardize at the top, I'm just gonna create a constant called JSON file name, where I'm gonna put in my file path. So in this case, the data is contained in my db.json file, which is under the web scraping and then under Selenium. So I'm just gonna put in my file name. Yeah, so by putting it at the top, it just ensures that in the future, if we need to change our if we are changing our file or the path changes, it's just easier to access and we don't have to scroll through our entire code and find that specific input. So next we can start by loading our data frame. So I'll create a function called load data frame. And then I'll pass in the file name, which so our first step would be to load the clues from the JSON file. So load clues from JSON file. Yeah. So I think similarly to what like Ashiu explained earlier, we can use with open. And then we enter in our path name, which would be JSON. And then we're just gonna read it. So and then we'll just specify the encoding. And then we'll put it in our JSON object. And then we'll use JSON.load file. And then since once we have loaded in our JSON data, we can create a data frame. So here we'll use data frame equals to pd dot div. So here we'll use list comprehension to create a list of tuples. Yeah, so here we need to specify hint. So this is where our hint 0, hint word, and hint 1 comes in, which we went through earlier. So here is the iteration. So for each word and for each hint in the hints. Here we will specify our columns. So as we mentioned earlier, we will name the columns hint, word, and answer. So this will make it easier for us to navigate through. Yeah, and since this is a function, we want to return the data frame that we have just created so that we can use it in another function later. So now that we have loaded our data frame, we can move on to create our search word functions. So here, and then in our search word functions, we need to pass in the data frame, which we have just created. So now we want to prompt our user for input, which they can use to search through the database. So we can use hint. So we'll use our input function, and then we can ask them to enter a clue or enter the clue that they want to they want to search for. And then we make sure to change that to lower. And then we will repeat the input for solution length. And also for solution letters. Yeah. And then now we can split the input hint into individual words. So here we can save the hint once it's split up into hint words. So we can do hint to search dot lower, and then we split it. Yeah. And then now we can filter our data, our data frame based on the input conditions. So first we have to initialize, let's call it filtered data frame, and then we just initialize it to the data frame we have already created. And then we iterate through each word in the hint word. So this ensures that we hack for every single word which the user has already inputted, and ensures that the solutions that we provide later has all of the keywords with that a user had provided. So here we let our field data frame, and then yeah, so we filter it based on the hint. And then we use our Boolean indexing here. Yeah, so we'll repeat a similar thing for both solution length and letters. So for solution length, we'll repeat this. But instead here, we'll be checking for our answer rather than the clue. And then we use apply length. And then we have to make sure that it's equal to the solution length which we prompted the user for previously. Yeah, so we repeat this for solution letters. Yeah. So now we want to keep track of the unique solutions using using a set. So here we do unique solutions. And then now we want to check if what we should print out to the user. So if the filtered data frame, so yeah, the filtered data frame is empty, then we can print no matching solutions. And then we can return. However, if it's not empty, you want to print out what we have found. So here we can do it. So we do this by before we print anything out, we just want to make sure that everything that is inside our filtered data frame is also inside our unique solution, so that it isn't missing anything, and it should only be removing duplicates. So we can just double check that here by iterating through every row in the filtered data frame and just making sure that it's inside our unique solution set. So if it's not inside, what we want to do is add it to the unique solution set first. And then after that, we want to print out everything that matches. Yeah. So that's basically it. So now what we want to do is just call the function. So here, what I want to do is I call the load data frame function. So this will be where I specify in the JSON file name. Yeah. Then I'm gonna change these variables to just like file name, so that um what data we load into a data frame will depend in what input we have provided. And then I would just do a while true loop that allows us to continue searching for more words. So yeah, so it will break if the user puts in anything that is not a Y. Yeah, so this is basically it. Now we can kind of search through everything. Ah, missed something. Give me a second. Ah. Oh, sorry, just a typo. Let me just check. I think there's some. It doesn't. And then in the open. Oh, sorry, give me a second.
I think you might be able to like right
Oh,
click.
wait, yeah, I just like spelled some stuff wrong. Just some typos. I'm so sorry. Yeah, okay, so now from here, okay, let me just check what clues we have. Yeah, so from here we can kind of look through. So if we're, let's say, um here, so if we had a hint called yeah, so let's just say we're searching for this hint, but maybe we only have the words like type a new tab, something like that. So here we can just write type new tab, and then let's say we are not entirely sure of, oh, but okay, let's say the length of our solution is 3 and we have no clue of any characters in our solution. So then this will give us the solution, which will be URL, and then we can choose to search again or no. So if you want to search again, yeah. So that's kind of just how it works. So now we can search for the clue for the solution based on any clues that we have, and we'll be able to go through our database. That's it for here.
Okay, awesome. Thank you. So I'm just gonna share my screen again really quick, just for some quick parting words. Um, so I like to end things on a moral. And that moral is that ah, web scraping is a bit tedious and can be kind of annoying to write web scraping apps. Sometimes you have to do it if there is no like API, like I mentioned earlier. But the positive is that you can make cool stuff, right? Like I think a crossword solver, although we didn't make it today, we made a crossword tool today. I think it's pretty cool. So yeah, hopefully this inspires you to make something of your own. Or I really do encourage you to try to, scrape the crossword on your own. Try to really solidify the concepts that we talked about today. That's the only way you can do it is if you learn by doing, right? That was originally the goal, but since we're on Zoom, you know, we make do. So yeah, hopefully you enjoyed, and we will see you back at 1:30 for some computer vision stuff. So yeah, thank you.
If you do want to come to the OpenCV, we will have a different link. It is shared in the announcement that we made, and it will post it on the Discord as well. You're also feel free to ask any questions you have right now if you want. And if not, hopefully see you in about 15 minutes. Thanks for coming.
All right, so are we just gonna chill in here until, or do you wanna take a
I'm
break?
not. I'm here. Let me stop the recording real quick.